Great. Okay, so it's my distinct pleasure to welcome Danaë Metaxa to virtual Hopkins to give a talk. Danaë is a PhD student at Stanford, where they're a member of the HCI group. Danaë's interests focus on building and understanding socio-technical systems and their effects on users in domains like employment and politics. They've been a pre-doctoral scholar with Stanford's program on democracy and the internet, a fellow at the McCoy Center for Ethics and Society, and won a NSF grad research fellowship as a PhD student. They've published extensively at CHI, CSCW, and other good HCI venues. And I think that includes a best paper honorable mention at CHI 2020. So welcome to Hopkins virtually, and take it away.
Thank you. Thanks so much for the generous introduction, Mike. So hey everyone, thanks for having me here today. I'm Danaë Metaxa. As Mike said, I'm a PhD candidate in CS at Stanford, and I'm going to be talking today about my work on bias and representation in socio-technical systems. And as an introduction, I'd like to start by telling you a little bit about how I arrived at this topic of study. So the computer science department at Brown, where I earned my undergraduate degrees, has this tradition of giving each course a fun theme every year. This was generally a very popular move with students. We had topics from pop culture like television shows or web comics. And I really enjoyed most of these myself, but inarguably some of these were a little bit intense. So, maybe this James Bond themed course, although honestly, I think that's very clever for a security class. Or this one that was modeled after Star Trek. Or maybe especially this particularly intense Matrix theme. It gets worse. I hope you can see this animation that actually ran in the background of the website at all times. So these were all real course websites while I was at Brown. And, far from having any particular issue with the Matrix or with Star Trek, it was that despite the really fun environment, I had noticed that a lot of my friends in those courses ended up dropping the course or dropping the major. And this seemed especially true for the women in my classes. I had also noticed, of course, that there were very few women faculty or teaching assistants. And somehow, given that context, some of those websites just gave me a feeling of intuitive unease. I knew that had nothing to do with the material of the course, but it was still just kind of lingering there. And years later, when I started my PhD, I came across a concept from psychology that really helped me give language to that intuition. So ambient belonging is a term that describes a feeling of fitting in with a culture or a community that's passively elicited by the surrounding environment. And this is a concept that comes from a broader literature on belongingness that goes back to Abraham Maslow's hierarchy of needs. So belongingness is this psychological need to be accepted as a member of a group. So at the start of my PhD, I found this prior research that had examined ambient belonging in physical spaces like professors' offices. So Cherry et al. Found that students' sense of belonging could be negatively impacted by classroom cues. Stereotypical cues in offices and classrooms, from the books out on the table, the posters on the wall. These could have a negative effect on potential students, and in particular, students from marginalized groups. Now, obviously, classrooms and offices are immersive, and they reflect some personal information about an instructor in a way that web pages aren't and don't. But based on that idea, I decided to design an experiment to see to what extent ambient belonging was transmitted through a user interface and what effects it might have. So I designed two versions of the same course webpage for an introductory computer science course at Stanford. The first one used pretty neutral imagery, and the second one stereotypical imagery. And both of these were designed and pre-tested to look appealing and engaging to students, and the content on the pages was the same. I only changed the aesthetic design. So my hypothesis was that these should have different effects on potential students, and more specifically that the stereotypical interface would be detrimental to women, but not to men. So that would mean, hypothetically, producing some results figures that looked something like this, comparing those two interfaces, the neutral one in that lighter color and the stereotypical in the darker color. And I expected that there would be very little difference in the two bars for men, that's that pair on the left that are pretty comparable in height, but that for women, that pair on the right, I expected that the stereotypical interface would have a negative impact. On the x-axis, or rather the y-axis here, is a 7-point Likert scale, and that's for each experimental measure. So after interacting with one of those two websites assigned at random, I had participants answer questions on that 7-point Likert scale about a range of measures. Whether they would want to take the course, whether they expected they would feel comfortable in it, how well they expected they would do. and also some measures that were beyond the scope of that course. So whether they felt confident in their technical abilities, whether they even had an interest in studying CS, and finally, whether they'd be judged according to gender stereotypes in that discipline or whether they expected that. And I'll note that, instead of potentially impacting a whole cohort of actual Stanford students enrolling in a course, I ran this experiment using crowd workers of undergraduate age in the US. So what I found was striking. Starting with these course-related measures, women who were exposed to the stereotypical website suffered. And as you can see, for each measure, that rightmost darker bar that corresponds to women who saw the stereotypical website is statistically significantly lower than all of the others in the figure. So that means that they reported lower intention to enroll, less sense of belonging, less anticipated success relative to all other students. And moreover, women who saw that stereotypical website were also negatively impacted on longer term measures. These ones had ostensibly little to do with the course. So they said they were less interested in CS as a field, less confident in their technical abilities. They expected to be much more stereotyped in the discipline. And all of these effect sizes were moderate to large as any in the prior work on ambient belonging in physical spaces. I'll also just kind of point out here that exposed to the neutral website, so just comparing these green bars in each figure, women's and men's responses were actually mostly comparable with few statistically significant differences, if any. So for a field that really emphasizes its pipeline problem, it's impressive to note here that I didn't see any evidence of pre-existing differences by gender. So I was able to conclude that gender bias could negatively impact people's sense of belonging in a user interface. But of course, belongingness is not something that's specific to gender. So a wide variety of biases can be conveyed visually and impact belonging. Consider, for instance, the effect of an image like this one. These are Paul Ryan's interns when he was Speaker of the House. And think about the effect on a young person of color who wants to enter government and really doesn't see themselves represented in that image. Or this very grandiose and beautiful image from the Rhodes Scholarship website. What effect would that have on a promising student of lower socioeconomic status who's never stepped foot at a place like Oxford, and that person's sense of belonging in a community like the Rhodes Scholars? Visual cues in online systems can have unanticipated and unintended consequences on users across a range of dimensions. So that project launched further work from other researchers, for instance, Renee Kislaketch at Cornell, studying psychologically inclusive design. But it also launched my own research focusing on bias in sociotechnical systems and its psychological effects. So what are sociotechnical systems? Broadly, these are systems that shape and are shaped by users. So they interface directly with the user, and they are in turn often shaped by user behaviors. This includes, for instance, search engines and social media sites. And in my work, I try to close that loop, studying the system and the user. I combine building systems with behavioral science theory and methods focusing on users to address high-stakes social issues in sociotechnical systems. And in doing so, I seek to answer two main questions. The first one, what content do sociotechnical systems produce? The second one, how does that content impact users towards building systems that do better? Now, traditionally in a software system, we're used to asking the first question. We know what it means for a system to work. And of course, we conduct tests and do monitoring to verify that it does actually function as expected. Sociotechnical systems, though, they're in this loop with users. The user is literally part of the system. It's not enough that the platform just functions. To evaluate them effectively, we need to ask first what its outputs look like at scale, and second, what influence that has on people. So by answering these two research questions, we can learn how to build sociotechnical systems that have positive impacts on ourselves and on our communities. Now, before I give you a roadmap for the rest of this talk, let me explain why this work is so challenging. In the example we started with, comparing two websites, we can see that content that's created by a single person, like a course instructor, can communicate bias and undermine belonging. But this is not an individual scale problem. Most sociotechnical systems today aren't showing us hand-curated content. They provide us with content that's been selected and organized algorithmically. And we rely on that algorithmic content for basic social functions, from connection to family and friends, to gathering information, to civic engagement. In the US, as of 2019, over 70% of Americans used some type of social media, and a similar proportion got some of their news through social media. And as of 2012, which is unfortunately the most recent Pew data on search engine use, over 90% of adults use search engines. That's a number that somehow is probably even higher now. And over 2/3 of those searchers considered search engines to be fair and unbiased. But we know these systems do have significant biases. We've started to see concern about bias along the lines of gender, of race, of political affiliation, and more. But studying these systems, going beyond criticism to precisely measure the content they produce and quantify the impact this has on users remains a challenge. I see 4 key problems here, 2 on the side of the system and 2 on the side of the user. So first, these systems are dynamic. They change constantly, and this can pose significant technical challenges in trying to study them. And second, their byproducts are ephemeral. A user's experience of a news feed or of search results disappears without a trace after that interaction, and there's no way to examine it retrospectively. Now, on the side of the user, these systems are embedded. They're in a loop with users, and users are interacting with dozens of such systems simultaneously in a single browser or on a single device throughout their daily lives. And finally, they're personal. Each user's view of the system is unique, and in fact, the impact it can have can be very different from one person to another. So to meet these challenges and close that loop of socio-technical systems research, we need interdisciplinary solutions that tackle both sides of that equation. And this is what I do in my work. In this talk, I'm going to show you what this looks like in practice, touching on 3 projects from my PhD. So first, in the introduction, I described my work on belonging and bias in web interfaces. Next, I'll go deeper into my recent paper on race and gender representation in image search results. And finally, I'll bring in some of my work on partisanship in political search results. So let's move on to that second project on race and gender in image search. One social issue that's received attention in various fields is visual representation, in particular, the representation of marginalized groups in media. So as I showed in my study of course pages, visual cues can impact belonging. And in the field of advertising, prior work has shown that representing marginalized people in college brochures can make a university seem more appealing to students. The same thing has also been found to be true for employees at a company and for customers of a business. So these cues are important for marginalized people. They indicate that an organization might be more welcoming to them. But importantly, the effects of visual representation are not restricted to those groups alone. Visual diversity signals inclusivity to everyone. Now, given the importance of algorithmic systems like search and my interest in visual representation, I was drawn to work on image search results. Do image search results accurately reflect real-world diversity? Prior work from 2015 had identified that search results for occupations exaggerated gender stereotypes. And since then, often in response to research findings like this one, Google has made various changes to their algorithms. But we might ask, are image search results still biased in their presentation of gender? Moreover, our field has chronically left race understudied. Do image search results accurately reflect real-world racial diversity? To answer this question, I first needed a ground truth data set with which to compare results. The US Bureau of Labor Statistics tracks demographic breakdowns of several hundred common occupations: doctors, lawyers, real estate agents, what have you. So based on that BLS list, I set out to collect image search results from Google using as the query term the name of those occupations. In my introduction, I described the process of identifying bias in hand design content, but in this case, I wanted to study the composition of hundreds of images for hundreds of queries. This is where studying algorithmic content becomes technically challenging. So to accomplish this, I built infrastructure to collect that algorithmic data. That pipeline for automatically collecting and processing image search results begins with a scraper to query Google with each of those query terms and capture the resulting top 100 images. To avoid personalization from repeated searches, I used a Selenium WebDriver here with separate sessions per query. And that scraper saved each image to cloud storage, where they were then automatically retrieved in the next step, which is data annotation. So to annotate that data, I recruited crowd workers through Amazon Mechanical Turk, with 3 workers randomly assigned to label each of those 1,000 images. I elected to use crowd workers here rather than image processing or ML because ultimately I'm interested in how other people perceive these images. Although, I'm also interested now to see where automated tools could take us on this sort of task now that I have a data set that's been labeled. So for gender, crowd workers were asked to label whether each image showed a woman or not, and for race, whether the image depicted a person of color or not. This is obviously a reduction down to a single bit. Does this image represent a marginalized person? Yes or no? There are many ways to potentially improve that strategy in the future, but I used this binary categorization because while both race and gender are spectra, in each case, there's a single dominant group that others are marginalized in relation to. And I collected up to 3 labels and considered this annotation to have reached consensus when 2/3 agreed. And finally, after eliminating occupations whose image results didn't show enough people or enough people of discernible race and gender, I settled on a list of final occupations. I made sure that these occupations were not statistically significantly different from the full BLS list of occupations in terms of demographics. So putting all of that together, what does that look like? Beginning with gender, I had a list of occupations with their real-world workforce diversity from 0% women to 100% on the x-axis here, and I could map each point then to a place on the y-axis reflecting the proportion of women in image search results for that occupation. The colors of these data points, by the way, are just arbitrary to help you track them when they move in a second. And the diagonal line here represents perfect correspondence. This is where the data points would line up if image search results perfectly reflected the real world. So above this line are cases where search results overrepresented women, and below are cases where search results underrepresented women. Okay, so let's see some data. To give you a few examples here, receptionists are about 88% women, but Google images for receptionists were almost 100% women. On the other hand, women are 30% of CEOs in the US, but only 11% of search results. And women are actually more than half of bartenders, but only a quarter of search results for that query. Now, doing the same thing for race, we again have a set of occupations with their ground truth workforce demographics. And again, this diagonal dashed line is perfect accordance between BLS and Google. So above that is overrepresentation and below is underrepresentation of people of color. So again, we can map that to demographics observed in search images. You'll note, by the way, that the axes here don't range from 0 to 1, but go up to 40%. And that's because people of color are only 22% of the US workforce. So there aren't records for occupations that are more than 40% POC. And what we see here for most occupations is that people of color are underrepresented in images. So take chefs, for instance. People of color are highly represented in that occupation at 37%, but they're still heavily underrepresented in search. There are, of course, some cases like among librarians where we see that people of color are a very small fraction of librarians in the US, but Google overrepresents them in search. So to quantify now the degree of underrepresentation in both cases, I fit generalized linear models to this data, predicting Google's representation from BLS data. And looking at these figures visually, we can see that generally there's an underrepresentation of women and people of color relative to the workforce, obviously much more strongly in the case of race than of gender. So in order to test whether the model's prediction at the overall workforce average, that's the vertical dotted lines, was statistically significantly different from proportional, that's the diagonal line, I examined the model's predictions at that X value and found that indeed these predictions are statistically significantly lower. So to summarize that for digestibility, we can say that for an occupation with 50% women, this model predicts that images will show 42% women. For an occupation with 22% people of color, the model predicts that images will show 16% people of color. And in both cases, these differences are statistically significantly different, even more strongly in the case of race than of gender. So going back to this first question, do search results reflect real-world diversity? In this data set, we find that no. Images systematically underrepresent women and people of color relative to workforce participation rates. The process that I'm using to answer this first research question about the content that some system produces, this is called an algorithm audit. So algorithm audits are the process of providing repeated inputs and measuring outputs of an opaque system to draw inferences about its inner workings. Auditing, without the algorithm part, is a powerful tool that's been used in the social sciences for decades to identify discrimination in employers' hiring practices or lenders' loaning practices, for example. And in the context of algorithms, we adapt it to examine whether an algorithm displays bias. Having answered that first research question using an algorithm audit, in this project, I also closed that loop by connecting a second study answering this second question. How does biased content impact users, and how can we do better? So first, I selected a set of 10 occupations, 5 for race and 5 for gender, in which marginalized people are heavily underrepresented. I chose these as I felt they were among the most high impact examples, since women and people of color might already feel like they don't belong in those occupations. And I created a set of synthetic image search results pages using the actual images that were collected in the earlier algorithm audit study. So for each of these 10 occupations, I created 3 synthetic results pages. The first with images predominantly from the dominant group, another one with images predominantly from the marginalized group, and one with equal representation. And I designed a randomized controlled study for each occupation, exposing participants in the studies to one of these 3 conditions at random. After that exposure, I then asked each participant to answer questions about 3 measures of interest on these 7-point Likert scales. So first, I asked about their perception of how inclusive an occupation is. Second, their interest in joining that occupation. And third, whether they felt they would belong or be valued in that field. So what did we find? First, let me briefly explain how to read these figures I'm about to show you. The first dimension I varied is gender, and that's shown along the x-axis here. So by tracking that line, we can see how participants' perceptions of an occupation's inclusivity changed as the proportion of women in those search results increased. Second, each of those search results also had some distribution of racial representation. And that's shown here with these 3 different lines that show participant response on the outcome measure as the proportion of people of color increased. So reading this figure together, what do we conclude? We find that greater representation of marginalized groups makes occupations seem more inclusive across the board. So reading these 3 lines left to right across the figure, we can see that participants' expectations of inclusivity generally increased the more women they were shown. Next, examining those 3 lines separately, we find that showing search results with greater representation of people of color also had a positive impact on inclusivity. In particular, showing medium or high levels of people of color's representation had a positive effect on perceived inclusivity relative to low levels of racial representation. And I also validate these findings statistically. So fitting a linear model to this data that predicts perceived inclusivity from those 2 features, both race and gender in images had a positive and statistically significant impact on expectations of inclusivity in a field. You'll note also that this is obviously consistent with that prior literature about visual representation making organizations seem more inclusive. Next, let's look at results in the same format for this second measure, participants' reported interest in an occupation. So here we actually find somewhat different results. While increasing racial representation does slightly increase interest in a field, as you can see from these stacked lines, increasing gender representation actually had a borderline negative effect on people's interest in the field. And again, fitting a model to predict interest from gender and race representation in the stimuli, I can confirm that finding. In this case, search results with more women did not have a positive effect on this outcome measure. So what might explain that effect? One possible explanation is occupational feminization. This is a set of theories in social science that describe the cultural turn that happens when women become more represented in the workforce, and the closely related idea that pay and other status markers in an occupation decrease as women's representation in them increases. So although we might have reason to believe that increasing women's representation in image search results is a normatively good idea, in some cases, it can actually empirically lead to counterintuitive and even counterproductive outcomes. Now, going back to this setup, there's actually one piece missing here. Importantly, in addition to exposing participants to different conditions and collecting their responses, I also collected demographic characteristics like race and gender for each participant. So while the previous 2 results I showed were largely consistent across participants, on issues like belonging, I hypothesized that people from marginalized groups might be affected in significantly different ways than those who aren't. So next, I'm going to show you the last 2 findings about participant sense of belonging, specifically examining differences by the participants' race and gender in addition to stimuli. So first, let's look at sense of belonging as women's representation increased, separating participants by gender. As you can clearly see, women's representation in images had a significant effect on participants' sense of belonging in the occupation, but that effect was heavily moderated by participant gender. So when shown search results with very low representation of women, men participants were much more likely than women to say that they felt they belonged. But as I increased the proportion of women in those search results, women's belonging increased while men's decreased to the point where they almost converged. So we find that women's sense of belonging improves with greater representation, but men's declines. What this means is first that we can actually compensate for pre-existing differences in gendered perceptions of belonging by increasing visual representation of women. But what it also means is that increasing women's sense of belonging in this way might happen at a noticeable cost to men's sense of belonging. So again, fitting a linear model to this data, we see that gender in search results and participant gender both had a significant effect on sense of belonging, as did the interaction of these two. And finally, I did the same analysis for race, separating participants by whether they identified as white or people of color, and examining the effect of increasing racial representation in image search. Unlike the case of gender, though, I didn't observe a significant effect of image diversity on participants' sense of belonging. Racial gaps in belonging were unchanged by visual representation. Across the board, what we see is that white participants report a higher sense of belonging than people of color, and no amount of racial representation in those search results could change that. And again, I can confirm that finding statistically. So to conclude, these findings confirm that visual representation in algorithmic content can change people's expectation of the world and of their place in it. But as we saw, there are also some important nuances. So first, more isn't always better. Greater representation of marginalized people can actually have deterring effects in some cases because of underlying social issues. Second, identity moderates effects. The same content might affect people differently from different identity groups. And third, there are cases where some existing inequities simply can't be addressed through some intervention. Technical fixes are not going to suffice for all of these big social problems. So as I've shown you, I use a combination of technical and behavioral science tools to answer these two questions: what systems produce and how it impacts users. And underlying that insight that visual representation impacts users, there's a key theoretical idea I want to draw your attention to. So users in that experiment I just described, as well as in other previous work, aren't consuming search results by scrutinizing each page individually or each image individually and thinking about, what source does it come from and should I incorporate it into my beliefs about the world? Instead, empirically, they're consuming the whole page at a glance. This whole page is essentially a single object. And in my research, I've given a name to this idea. I call this search media. So search media is the combination of headlines, text, and the ordering of results on a page that's experienced by users as a unified source of media, unified form of media. And theoretically, I form this definition by arguing that search media fits into a framework laid out by new media theorist Lev Manovich in 2001. New media is a widely used term that describes media forms that are native to digital technologies. So I won't go too deeply into this, but I'm happy to talk about it more later. I think it's really interesting. A couple of these points are that Manovich calls new media metamedia, saying that they're created by remixing existing media, so they're accessed in new ways. And search media does that, compiling results from a set of pre-existing websites or images presented together. New media forms also entail faster execution of something previously manual, and search results obviously are doing that. And the last one that I just found fascinating was the idea that new media forms often have parallels to ideas and envisioning from post-World War II, 1940s and 50s. So if you're familiar at all with Vannevar Bush's Memex, you can kind of see how search media tie back to that. So when users think that search results are largely unbiased, and then they draw inferences about the real world from that mosaic of images in search, consciously or not, they're treating search results as a type of media. And that positions Google in a role similar to that of a newspaper publisher that presents users with a sort of front page for each query. There are various legal and policy reasons that I can touch on later or talk more about in Q&A, for which Google would heavily resist that characterization that they do something similar to a newspaper. But I would say that this is what the data suggests is how users psychologically experience search. So in addition to policy implications for Google, this has implications for how we conduct and analyze algorithm audits. So instead of focusing on just one part of the page or weighting the top and bottom equally, we need to think about how users are actually consuming that content. For example, considering the whole page, weighting results at the top more than ones at the bottom. And this idea about search media and the algorithm audit strategy for studying it, these have implications in many domains outside of visual diversity. So another area of interest for me is politics. In the political context, one important kind of representation that matters is the representation of political perspectives. And the potential for bias happens along partisan lines. So in the last project I'll touch on today, I studied political partisanship in search media. In 2018, then US President Trump tweeted about Google. He made a series of claims on Twitter that, of course, were picked up by major news outlets around the country, alleging that Google search was biased against conservative perspectives. And given that contentious political context, I did an audit of partisanship in search. So again, to find a real-world data set of importance, in this case, I collected the names of each candidate running for federal office in the US 2018 midterm elections, every candidate running for House or Senate in any state that year. And to collect that data set, I built infrastructure to perform queries with those politicians' names, collecting the first page of search results. Scraping that data at scale entails several technical challenges. One risk is that Google will identify that irregular activity and block your scraper. Another is that a single machine conducting each of these 3,000 plus queries wouldn't actually finish in the course of one day, and I wanted daily scrapes of that data. So to do that data collection of over 3,000 pages of search results daily, I used 5 scrapers instantiated using Amazon Web Service EC2, right, machines in the cloud. And I was coordinating between them so that the scrapers rotated through a list of IP addresses and user agent strings to appear as though those queries were coming from a set of over 20 actual machines. I also instituted a random wait time of about a minute between queries, because rapid queries with little wait time, as I've learned over the course of my PhD, especially early on, is a really guaranteed way to have Google detect and block that irregular behavior. And finally, each query included a depersonalization parameter, as if we were querying in incognito mode, to prevent personalization by the history of queries. I wasn't too concerned about other kinds of personalization in this case, because prior work had shown that generic political queries like these are not very personalized. So using that infrastructure to collect thousands of search results daily, I repeated that data collection every day for 6 months leading up to the election for a total of over 4 million URLs. And finally, I used an established metric to label each of those URLs with a partisanship score, a measure from very liberal to very conservative that describes the ratio of liberals to conservatives who normally engaged with that website. I'm sure you'll notice, by the way, that this third step relies on this binary 2-party system. And since these queries were US specific candidates, that makes sense. But there's still more interesting work, I think, to be done to adapt these methods for other political systems. So I did this with the goal of investigating the set of sources from which search media was being compiled for these political queries. What sources does Google draw from when it's creating search media for political queries? If Google was very biased against conservative news, we might expect there to be very few sources on the right side of this figure. Or if Google showed large partisan differences for Republicans and Democrats, maybe that would reflect some disparate treatment of political groups. But instead, what we see is that search media drew extensively from conservative sources, regardless of query. And as you can see, this pattern looked roughly the same, regardless of the affiliation of the candidate that was being searched for. So we don't see evidence of that conservative, anti-conservative bias. So you'll remember I said I collected that data daily for 6 months leading up to the election. My reasoning for that was that I was interested in whether there were temporal changes over the course of the election. And I did find some evidence that political events that affect individual political candidates changed their search media. But rather than going into a whole set of case studies here, I'll just touch on one more very striking trend across that whole data set. Here we have the average partisanship of each page of search media, weighting each individual search result by its order on the page. So a page of more partisan search media would be a data point higher up on this y-axis, whereas a more moderate page would be lower. Let's look at partisanship over the course of the election for candidates who went on to win their elections versus those who lost, right? This is an obvious measure of interest or feature of interest for anyone looking at politics. As you can see, search media clearly differentiate these two groups. Election winners have more moderate search media throughout the election than do losers. Now, before you get excited and quit your academic career to start the next 538 election prediction service, I have to tell you something that political scientists in the room would recognize really well. And that's that it's a well-established fact that election outcome has a very strong correlate, and that's incumbency. So incumbent candidates actually win upwards of 90% of the time or even more. So if we separate candidates out by incumbency, we actually find that this is the main driver of that trend. Search media differences reflect incumbency. Incumbent candidates have much more moderate search media than do challengers or those running for open seats. And this finding empirically demonstrates a pattern that's been theorized in political science. That's that challenger candidates, whose road to electoral success involves first winning a primary election where only members of their party are voting, These candidates are incentivized to take more extreme partisan positions. Incumbents, on the other hand, are looking to win a general election where citizens from both parties will be voting, and they should take care to come across as more moderate. So in short, the findings from this study demonstrate that algorithmic content reflects real-world information and reveals insights that speak to theory from other disciplines like political science. And overall, algorithm audits are a multi-purpose tool for studying bias in socio-technical systems. A quick note here on algorithm auditing. Conducting effective algorithm audits is technically challenging. So what do you measure? How do you collect that data? How do you manage data at that scale? How do you analyze it? And at times it's also theoretically and ethically challenging as well. So it usually involves breaking a platform's terms of service, which historically has been illegal. Based on my experience in this domain, I've brought together a team of leading algorithm audit researchers from 4 universities, and we've written an authoritative piece on algorithm auditing, including its history, best practices, ethics, and norms. So if you're interested, you can look forward to that piece in the journal Foundations and Trends in HCI later this year. I hope by now to have given you a sense of my work closing that loop, studying bias and representation in socio-technical systems and their effects on users. So to close my talk, I want to cover 3 directions in which I'm continuing this research. First, in systems. I'm interested in enabling cross-platform longitudinal intervention audits. I'll tell you what that means in a second. Next, in theory, developing and contributing to theory that bridges computer science with behavioral science. And finally, in policy, contributing to public service and influencing industry. So as I said earlier, there are these 4 key challenges studying socio-technical systems: dynamicity, ephemerality, embeddedness, and personalization. And research like mine closes that loop, connecting the socio and technical parts of those systems with a combination of techniques like auditing and user experiment. But the overhead to doing that work is really significant. So for each platform, you need to build custom infrastructure, and this generally means you can only study one platform at a time. And in order to control the stimuli that users see on the other side, you have to run experiments in highly controlled artificial experimental settings. So as the last project in my thesis, I'm currently in the stage of testing a platform I've developed called Intervenor to connect these pieces. Using a combination of a browser extension and a web interface, Intervenor allows researchers to recruit paid consenting participants and audit the content that they see online, and also conduct randomized experiments across a group of participants by changing the content they see in real time in the browser. So the goal here is to provide infrastructure for conducting cross-platform audits and experiments in real time, longitudinally, during people's real browsing for actual users. So Intervenor works by walking users through an installation process in the web app that collects demographic information and guides the user to install a Chrome browser extension. Once that's installed, the browser extension collects information for each page of the user's browsing. That can include the URL, the previous URL from which the page was accessed, and select information on the page that's customizable by the researcher. So this can include anything from links that appear on that page to text on the page or images that appear there. And that data is set to encrypted servers for analysis as the user browses. In addition to that infrastructure for auditing content in browser, the extension is also able to inject HTML onto the page, so adding notes or pop-ups or changing the images or text that appear. To execute those interventions as randomized experiments, on the back end, users are assigned to an experimental condition at random, and they receive interventions accordingly. And on top of that, I'm building in compatibility with the Qualtrics API so researchers can design sophisticated surveys and deploy them to participants throughout the experiment. One application I'm really excited about here that I'd like to touch on is online advertising. So we've all probably noticed or heard at this point that marketing and branding is often heavily gendered. And more than that, we expect that the content in ads should have some psychological impact. That's kind of the whole point of advertising. So given that backdrop and the harms that I've shown can occur from biases in gender and racial representation in algorithmic content, I'm interested in whether browser ads shown to people display such biases, whether those online ads and biases differ for people of different genders or races, and what psychological effect those repeated exposures have on people. On the back end, there are only a handful of major players distributing ads like Google and Facebook. But existing algorithm audits can only capture data from one platform, and often that data is sort of a good stand-in for what all users see. In the case of advertising, those assumptions break down, right? Because that content is being shown across the entire web to users, and it's highly personalized. There's no default that you can really collect on. So this is a perfect use case for Intervenor. Intervenor will make it possible for the first time to to collect and analyze gender and race representation in ads as people are exposed to them in real time for a group of real users, taking into consideration those people's demographics. And going further, it'll let me intervene, showing those people different ads to causally demonstrate the effect that such ads can have. I'll also just note briefly here as a quick plug that I've been working on Intervener with a small team of undergraduate students, and teaching and mentoring is a central motivation for me in choosing this career. And I've really been just blown away by the quality, enthusiasm, and super wide range of students who are interested in working with me. So for me, that's one of the strongest signals that I'm doing something right in my work. Now, in addition to theory on representational bias and sense of belonging, which I've described in this talk, there's a couple other theories from behavioral science where I see my work contributing that I'd like to draw attention to. So two of those are perception, self-perception theory, and identity shift. So when we're evaluating other people, we don't have a complete picture of their internal state. And so we have some heuristics, we make some assumptions based on the way that we see them behaving in the world. Self-perception theory proposes that that's also what we do internally towards ourselves, so that our own actions in the world shape how we view ourselves. And identity shift is an extension of this idea in the digital realm, suggesting that our self-perception and future behavior is shaped by our behaviors online, as well as by the feedback that online systems give us. So looking at that same example as before, I'm interested in what happens to users' sense of belonging or sense of self, rather in this case, through repeated exposure to advertisements. So for instance, in the context of education, do ads for educational opportunities make people more likely to pursue their education or more likely to think that they're the type of person who values education? And if so, do these sorts of ads get served to different types of people at reasonably equal rates? Do they have different effects then for different types of people? Sociotechnical systems, as we've said, are so deeply tied to both software and to society. And so to understand them, we need to consider both. And finally, not only is this work interesting, I think, technically and psychologically, but I also see important connections to law and policy. So for instance, I recently consulted as an outside expert for the New York City Commission on Human Rights in a case where a popular microblogging platform started automatically flagging content that disproportionately harmed users from a particular marginalized group. And they wanted help understanding how to audit and address that problem. I've also co-authored white papers with policy-focused colleagues at Oxford and political actors like Senator Russ Feingold on self-regulation in the tech industry. So moving forward, I'm really keen to continue working on law and policy with experts in those areas on the intersection of my research and those issues. So, that went backwards. To summarize, these are only 3 research projects that I've carried out in these areas. The first is to show how psychologically inclusive versus alienating design could impact people's sense of belonging in a course. In the second, that race and gender biases do appear in algorithmic content and can have detrimental effects on people in the context of employment. And also that different levels of representation can cause both positive and negative psychological responses for different users. And third, that building systems for auditing bias in algorithmic content is also a useful tool in cases where some alleged bias isn't observed, and that such content can reflect real-world and theorized trends. Sociotechnical systems and algorithmic content that they produce, these are going to continue growing as one of the main sources of educational, professional opportunities, civic engagement, and more. So when we study it, it's vital that we consider both sides of this equation, the system and the user, and that we do so keeping in mind and in focus the experiences of marginalized users. This is the central aim of my work. By closing the loop between algorithmic content and its effects on people, we can build sociotechnical systems that have positive impacts on ourselves and on our communities. Thank you.
Let's thank Danaë virtually as best we can. And yeah, it's time for questions.
I had a question. I put it in the chat at the halfway through the talk, so I wouldn't forget it. I don't know if you can read it, but
Yeah.
In your searching, trying to look for bias in image searches, I was just wondering, because when I do a search, if I were to search for chef, I assume I would get like famous people. You know, it might be a very small number of people that dominate those images. So how do you control for that?
Yeah, that's a great question. I found that kind of empirically doing these searches, actually you get pretty generic, almost like stock photo image type of images. So I didn't see too much of that effect of really noticeable sort of famous people. Although, you know, you can imagine that that might be the case for some of these queries. And I'm not controlling for that in this case, because I think it kind of still fits in with the overall construct that I'm interested in measuring, right? The reason that search results are biased, I don't think it's strictly just, something about the way that Google is compiling those pages. It also has to do with what they're working with and what set of images exist on the web. And so in cases where there are real world, discrepancies or real world trends, we're definitely going to see those reflected in search. And kind of the next question that I have then is like, okay, well, is Google sort of liable? Should we ask them to do something differently then? And I would argue that given the effect that this can have on people, there are some cases where it's reasonable to ask Google to do something different. There are also cases where, maybe that's not the case, and it's reasonable to expect that some system like search is going to just reflect the content that's already out there on the web. Yeah, thank you.
Okay, thanks.
So I had kind of a related question about the image harvesting. Can you say something about images of individuals versus groups? It seems like all the examples that you were showing were images of individuals. And I wondered if there might be like a prototype effect where if you're just going to show, one railway worker, it has to be a typical railway worker, or you're not going to pick the person from the smaller group if you do that. But if you have a group of people, then maybe there's even an active effort made to ensure balance or possibly even affirmative representation.
Yeah, that's a great point. This, I would say, is a limitation of the work, because I did think about what happens if I should say the reason that the images you saw had only singular people is because in that second study, when I was synthetically creating those, I selected images that only had one person at a time. And that goes back to the first study, which is that when I was doing that analysis, in terms of proportion, there were not that many images actually that were showing multiple people relative to those that only had one. This was, I didn't, mention it to get into the nitty gritty, but I asked crowd workers in that annotation step first, actually, how many people are in this image, and then what kinds of people appear. And I was only keeping images that were labeled as having one type of person. So it could be multiple people, but they're both men, or cases where there's only one person at a time.
I see.
And the reason for that is that if you start trying to sort through images that have multiple people, you get into a bunch of kind of hairy edge cases. For instance, with doctors, let's say there are two people in an image, one of them is wearing a lab coat and the other one isn't. You can imagine a case in which actually maybe both of them are doctors. But if you're trying to ask a crowd worker, what is the gender of the doctor in this image? Maybe they're going to overlook the fact that the second person has a stethoscope because it's a woman and they already don't think women are likely to be doctors, and so they're gonna say, oh, the man is the doctor, right? And so you kind of get this bias that comes from the labeling there. So that was the reason for sort of selecting, specifically looking at images that are uniform in their presentation of just one type of person. But this is something that, moving forward, especially if I'm looking at doing this kind of annotation with some image processing, I think that we could try to sort of, kind of address that shortcoming there.
Thanks.
Yeah.
I had a question about your second project, the gender and race.
Yeah.
So there's this concept of matrix of domination. I've seen it in design justice books and stuff, where the gender and race axis kind of add. So women of color tend to have experience more injustice than women in general, or people of color in general. And did you see that phenomenon in the study?
Yeah, I did. I didn't include those visuals for the sake of kind of keeping the narrative a little more streamlined. But when I separate out into kind of both of those axes, white men, men of color, white women, women of color, if I graph all of those lines, they're essentially stacked in, unfortunately, the order that you would expect, which is to say that white men kind of have the most positive expectations across the board, and women of color the most negative expectations across the board. Yeah.
Do you also see that in representation, where there's the underrepresentation of race and of gender are not independent?
Sorry, say that again. Which section of the?
Yeah, sorry, I'll just phrase it more easily. So let's suppose that, I don't know, a police officer is being depicted. So there's some chance that they might pick somebody who's who's Black, there's a chance that they might pick somebody who's female, but they never pick somebody who's both Black and female because intersectionality.
Yeah. I don't think I have those. Those tables might be in the appendix of the paper. Yeah, I was looking at also like what's the proportion of those images kind of breaking down by both axes. And, in most cases, that's also the trends that we see. Yeah.
There's a couple of questions in the chat. Maybe Margaret or
want to say them
Alexandra.
out loud, or...
Yeah. Hi. So I was just curious about whether or not you looked at any of the metadata of the images. I was wondering, I was thinking about like the overrepresentation of librarians and whether or not that like particularly librarians might be the type of occupation that would include metadata and therefore be overrepresented in image returns.
Yeah, that's a great idea. I didn't look at any of that metadata. No, I wasn't collecting that data, but I can definitely see that there are some edge cases, in particular, let's say librarians, who might appear differently than the overall trend for some reason, like their general literacy with these kinds of systems. Yeah.
Alexandra, do you want to ask yours, or I can ask it if not?
Oh yeah, I can ask. Yeah, so I thought the work on belonging was really interesting, specifically in the classroom. And I was just wondering how to balance trying to be like a, I guess, cool instructor and try to relate to students with like pop culture, but also not alienate people. Is that balance possible, or should everything just be kept purely neutral?
Yeah, I would say, given my own, appreciation of the Brown CS undergraduate curriculum, I definitely think there's a way to do something that's engaging and fun and not like purely nature themed, that still appeals to different students. And the important thing is whether it's cueing stereotypes about that discipline or stereotypes about a certain type of people. So, I wouldn't say that it's like, oh, don't use any pop culture, any like TV reference, but maybe don't pick the ones that people are likely to rate as rather stereotypical of computer scientists if you're not trying to get a set of students who are also rather stereotypical of computer scientists. Yeah, thank you.
Okay, cool. Thanks.
Still have a couple minutes if there's any more questions.
Yeah, okay, so I'll ask a quick question, although I think we can talk more later. So very important and interesting topics. So curious about, did you look into, so you have those experiment, the data collection experiment, and then you identify the problem. Do you look at a bit more into, say, why caused that problem? Because I would imagine it could be a result of a function of business consideration and whatnot in terms of ad or in terms of other type of setup, right? So I'm just curious about how much you look into the cause of the issue.
Yeah, generally speaking, that's difficult, sometimes bordering on impossible to do when you study sociotechnical systems. The reason that we use something like an audit is because for the purposes of the external researcher, and honestly also for internal researchers at a lot of these companies, the process on the inside is a black box, and it's not very easy to understand how those different aspects are working. It's worth mentioning here actually that I was talking to a friend at Google who told me that internally in the company, when they make large changes to the search algorithm, they have a team called the raters, and the raters take scrapes of Google search and verify that, after this change to the algorithm, that the quality on whatever metrics they have, which I suspect are not the same ones that I'm measuring, that the quality is still high. And so this is a sort of fundamental limitation of studying a lot of these systems, is that that kind of internal view is often just impossible to get, even sometimes when you're inside the company itself.
Thanks.
Okay, so it's 1 o'clock. So let's thank Danaë again.
Thanks very much. And please feel free to email me if you have any other questions. I'd love to talk about this more.
Great. So thanks everyone for attending. Have a wonderful rest of your Friday and weekend.